we're going to look at a specific type of quadratic expression that we'll see. This is a difference of squares that has a pattern, so it's kind of considered a special case, but it's really not any different than the other factoring that we're doing. It just looks special. So a difference of two squares is coming from when we have something where it's like a squared minus b squared. Both parties are squares, and it's difference because it's subtraction between the two things. So this would always factor into something like a plus b times a minus b. So if we look at number 1, x squared minus 16, if I think about the traditional factoring that we have been doing, x squared came from x times x. And then we're looking at what things multiplied to give me a 16. Well, that could be 4 times 4. If we check the inside, I can get 4x. On the outside, we get 4x. But the linear term here is 0x. So we needed a positive and a negative so that it does combine to give me 0, which is how it's following this traditional pattern of a plus b, a minus b. So this just factored into x plus 4 times x minus 4. All right, number 2 still is one of those difference of two squares, because as we look at this, 25 n squared is a perfect square, and 4 is a perfect square. 25 is 5 squared, 4 is 2 squared. So if you factored 25 n squared could be 5n times 5n, and 4 is just 2 times 2. We needed them to combine to be 0n in the middle. Looks like on, but 0n. So positive 2, negative 2, that would combine and cancel out in the middle. So there's our factored form, 5n plus 2 and 5n minus 2. All right, 3. This looks a little different, but it's still a difference of two squares. Difference because it's subtraction, and 4 is a perfect square. A squared is a square. So if I factored, there's no need, you can move that around, but it would be, you cannot make that a squared minus 4. That's not the same. You can make that negative a squared plus 4, but then you'd have to factor out a negative 1, make that a squared minus 4, and factor again. That's just annoying. So rather than doing all that, just leave it the way it is. 4 came from 2 times 2. A squared came from a times a. We needed them to cancel out in the middle, so we have positive and negative, because that would be a 2a. This would be a negative 2a. Combines to give me 0a. So that's our difference of two squares there. It just looks a little bit backwards, but it started out backwards anyway. So 2 plus a and 2 minus a. All right, 4 has n squared minus 1. Now, we might forget that 1 is a perfect square, but it is a perfect square. So think about, how could you have gotten this? N times n is the n squared, but 1 is just 1 times 1, so that's why it's a perfect square. This makes this n plus 1, n minus 1. All right, there's 6 of these for you to practice, so if you pause the video real quick, you can try them out on your own, and then we'll jump back together and press play, and you can check your answers. All right, so for 5, you would have had 2x plus 5, 2x minus 5. 16 would be 4m plus 1, 4m minus 1. 7 would be k plus 10, k minus 10. 8 is x plus 8, x minus 8. 9 is 7 plus a, 7 minus a. And lastly, number 10 is x plus 12, x minus 12. Again, with these, you could have a GCF, so you still always want to look for a GCF. That's never going to change. Always make that your first rule of factoring, is looking for a GCF. But if there's not one, like none of these had a GCF, you would just continue factoring like normal.